So, so have you ever wondered how you can make sure that your task is completed even when the user exits the app? For example, you are uploading some data to server and user exits the app. You want to make sure that your task is completed even when the app is in background. When building an app, we want to ensure that we perform as much as work possibly in background because users typically don't want to spend much time on the app unless it's a social media app or any other engagement app. To build these functionalities, you may refer to official documentation and find that there are many ways to handle background work. And this can be a little overwhelming with all these APIs present, deprecated, and there are many scenarios to handle. On top of this, many restrictions are added by device manufacturers also. If you have had struggled with these kind of use cases, then you are in the right talk. Uh, what we will cover in this talk uh, is we will talk about what background work is. Then we will explore all the different kind of APIs which ensure background work. Then we will deep dive into different type of services which are recommended to handle different kind of work. We will also explore work manager. We will explore how you can choose the right API for your use case. And at the end, we will cover some real world scenarios to see how you can tweak these APIs to run in the background. What we will not cover in this talk is asynchronous work. Asynchronous work is basically anything you want to deferred from the UI thread. Example, if you want to call an API, you can do that via coroutines or OG threads. So let's talk about what background work is. So background work refers to the tasks that run without directly interacting with the user interface. Suppose you are building a music player app. So once users start a playlist, user can go in background and still can listen the music. We have several APIs to do background work. First, we have service, which is an Android component that can perform long running operation in the background without providing a user interface. Then we have bound service, which is an extension of service itself, which allows components to bind to any kind of component so that they can interact with service. We have another extension of service, which is foreground service, which performs long running operation which are visible to user. This is a go-to API to run immediate tasks, which we will discuss in detail. And then at last, we have work manager to run any deferrable task. So let's talk about service. So service, as I mentioned, is an Android component. It is designed to handle tasks that should continue running even when the user isn't directly interacting with the application. To create a service, you must next slide. Yeah. To create a service, you must create a class which extend a service Android service component. You then declare it in manifest, and you can start service with start service method. Service has its own life cycle, like activities. When you call start service method, it creates service, and then system calls on create method. It will be only called once, no matter how many times you call start service. Once service is created, system calls on start command. This method will be called every time you call start service with a different start ID. You can use that start ID to stop a particular service. It also returns an integer which describes what system should do if the service is killed by the system. For example, here we are using start seeking. So it will system will try to recreate the service after it's killed, but won't redeliver the intent in this case. I guess slides. Haitham. Okay, can you guys see slides? Hmm. Kimi, Hidam, if anyone's there.
1 minute, I had small technical issue here.
Yeah.
Okay, now we're back. Sorry for that. Okay,
Okay. We are at on start command. Uh,
okay, so we're here.
no, on 22 on destroy.
Yes, yeah, right.
Okay. So service can be stopped by stop self, which can be called in from within the service, or you can call stop service with the intent where from where it has started. After that, system will call on destroy in this case. While implementing a service, you should remember that it does not create its own thread and runs on the main thread of its hosting process. So if you are running any heavy task, you should delegate to it a separate thread. If your app targets API level 26 or higher, then your service will be killed if user exits the app. Now let's talk about bound service and why do we need it exactly. So bound service is as I mentioned, bound service is an extension of service which allows activities or other components to bind to that service and communicate with that service. For example, if you are building a music player app, again I am taking that example. You s- you stream you play the music on service, but when you user opens the app, when the app is in foreground, you want to make sure the controls is in activity, not in the service, to skip the music or to play next music. It also allows inter-process communications. Yeah. So to start a service, again, to create a bound service, you can extend service, declare it in manifest. It implements onBind method to return iBinder object, which was not there in our basic service. After on create method is called, on bind method is called. So what exactly is binder? So binder is a custom remote procedure call designed for Android platform. It allows you to call methods on remote objects such as service as if they were local methods. Like we will call perform operation on this in this service. This is called okay. Then there is on unbind method. This is called when all clients bind to that service called unbind service, and after this service gets destroyed. Next. To start a bound service, you must define a client service communication interface using service connection. It's an interface used to monitor the state of connection to the service. We have two methods inside service connection: on service connected and on service disconnected. So on service connected is called when connection with the service is established. This is where you typically get the iBinder that allows interaction with the service. This method is also called on main thread. So make sure if you are doing any heavy work, use a separate thread. Then on service disconnected is called when service is lost connection unexpectedly. This will not be called if if you call unbind service to unbind the service. Next slide. Okay. Yeah. To start a bound service, you can call bind service method, which has three parameters. Service intent, specify the service you want to bind. Then you provide service connection, which we just created. Then you have to provide a binding flag to determine how service should be bound. For example, in this case, we are providing bind auto create method. It automatically creates the service if it does not already exist. Yeah. You should always call unbind service to unbind from the service to prevent memory leak. As a rule of thumb, unbind service in appropriate lifecycle method to release reference to that component so that it won't cause any memory leak. Before unbinding service, you should always check if the service is bounded or not. Otherwise, it will throw illegal argument exception. Yeah, next. So you might be thinking, why haven't we talked about continuing work when user exits the app? After all, this talk is about that only. But these are building blocks of foreground service and is used in many use cases, especially bound service. So bound service, you can create if you want to create a service which shares the data or resources between multiple activities or even in different apps, you can use AIDL for that. Let's talk about foreground service. Foreground service is an extension of service. Which can run indefinitely if it is stored by system or stored by the user itself. But I don't recommend it to run indefinitely. How to start a foreground service? You can start a foreground service from a OG start service method. But starting from API level 26, there is another method which is start foreground service to specially create a start foreground service. Whenever you are creating a foreground service, you have to create a notification for that service to inform user that some task is running in background. You can create a notification using notification manager. Now, to create foreground service, you extend your class with service and then implement on start command. The only difference here is you call start foreground method with notification to promote service as foreground service. Before calling start foreground, make sure user has granted all the permission needed for that service type. We will talk about service type later. Remember, if you start service from foreground service method, you have to call start foreground service within 5 seconds. Otherwise, it will throw foreground service did not start in time exception. To avoid this, you can always start it as service and then promote it to foreground service. Android 10 introduced a foreground service type attribute within service element to categorize the service so that system can manage resources efficiently. And starting from Android 14, it will be mandatory to add foreground service type in your manifest. Also, later we might see that we have to add this service type in Play Console also. So what is foreground service type exactly? Foreground service type is a category. Next slide. Foreground service type is a category assigned to the foreground service that indicates the primary functionality of that service. Is Suppose if you are implementing a location service, then you should add location service type to inform system why your app needs to run continuously. Why they were introduced? They were introduced to enhance transparency by informing user why app is running in background. They enables better battery optimizations through categorized resource allocations. For example, a location service might be allocated more frequent GPS updates. It also improves privacy and security by helping identify suspicious background activity. Starting from Android 13, user can see all the running app from Task Manager and stop it. So make sure you handle that scenario and test it by ADV command stop activity. It also helps developers to understand valid scenarios to use foreground service. So let's see all the foreground service types which we have currently. We have location type. If your app needs to access location, such as delivery partner apps, you can use location type. If your app needs to access camera from background, such as video chat apps, you can use camera. But remember, it requires runtime permission, so you can't start it from background. Then we have microphone. If you want to capture or microphone, such as audio recorder apps, you can use microphone. To interact with external devices that requires connection with like Bluetooth, NFC, or any other network connection, you can use connected device. If your app needs to continue an ongoing call, then using connection service API, then you can use phone call service type. Then there's media projection. If your service needs to be project display on external device, use this. We have data sync to transfer any data such as downloading or uploading. This might be removed in future in favor of user initiated tasks and download manager. There were two new APIs. There were two new service types introduced in Android 14, which is health. Uh, if your app needs any, if your app is in fitness category, then you can add these service type, or remote messaging to transfer text message from one device to another. If any of your use case does not fall, if your any of these service types does not fall under your use case, we have some special cases. We have short service. If your work needs to be finished quickly and that cannot be interrupted or postponed uh, by system, just like finishing a payment, so you can use short service, but make sure you call stop service within 3 minutes. Otherwise it will throw a crash. You do not need any external permission for short service. You can start it from background, but the only condition is it has to be finished within 3 minutes. We are system exempted. These are reserved for system applications and specific to system integration. Suppose if your app has the profile owner or device owner permissions, or you have permission for exact alarm schedule, then you might use this. If still these does not cover any of your use case, then there is special use. It covers any valid foreground service use case uh, that aren't covered the other foreground service types. So to use that, you have to specify property element within the service element in manifest and add an explanation about your use case. You can read more about service types in documentation. I have added the link in slide, and I'll share that too after this. Before using foreground service, you must check if there's any alternative API to foreground service, such as user initiated data transfer API. So if you want to implement data sync foreground service type, instead of using that, you can use this. This API is used when you want to initialize a task by user action. So it allows the important data transfer to complete even when the app is not in foreground. It uses job service to run that task. To implement user initiated data service, you can declare a job service in manifest, define your job service class, declare run user initiated job permission in manifest. Then you set user initiated with building job info, schedule your job, set the notification during execution, update the job status, and complete. This is how you can add it in manifest. Then you can create a job info by setting user initiated to true. You can also add other constant to this. After that, you can schedule that job with job scheduler. Just like foreground service, you have to provide a notification to user initiated data transfer. So in OnStart job, you set notification using set notifications method. There are two more alternate APIs for foreground service. One is companion manager. If your app needs to do continuous data transfer to an external device, so consider using companion device manager instead of using connected device foreground service type. We also have telecom library. If your app uses for phone call foreground service type, you can replace it with telecom library, which provides a way to implement voice over IP using connection service. Now we will talk about work manager. I am assuming everyone have heard about this. Whenever you search about background work, it is recommended to use work manager. So it is a Jetpack library which is provided by Android for scheduling and managing background tasks in a battery efficient manner. There are some pros. Next slide. There are some pros of using work manager. It is battery efficient because it respects system level optimization like dose mode. It has flexibility to schedule a one-time task or repeated tasks with customizable constraints. It also guarantees that your work will be executed even after app is restarted or device is restarted. And because it is a part of Jetpack library, it is backward compatible. You can also have a retry mechanism where if your work manager is killed by system, it can be your work can be retried. You can implement that in foreground service, but you have to handle all the scenarios by yourself. There are some limitation using work manager. There is timing precision. If you start a work manager, it is not guaranteed that it will run on time because of quotas. We'll talk about quotas later. It also have a minimum frequency of 15 minutes to run a periodic work. So suppose if you want to run a periodic work every 10 minutes, you can't use work manager. There are two types of work. One-time work, which only runs once and then completes, like sending a log file to server. Then we have periodic work, which repeats at a specified interval. So you can send data at every 20 minutes to server or like that. To create a work manager, you have to define a worker class and implement do work method. You can create a work request, a one-time work request using one-time work request builder, or a periodic request and specifying the repeat interval type. Then you can enqueue that work using work manager. Work manager also provides some other features. So starting from work manager version 2.4, for high priority user initiated tasks which needs to be run as soon as possible, you can use set expedite and set out of quota policy. It will not guarantee that your work will be done immediately, but it will be done as soon as possible. You can also integrate foreground service with work manager. So for that, you have to call set foreground method with providing the notification in do work method. You can change your work. You can change your work. So suppose if you are making a payment and after payment is successful, you want to send some data to server. You can specify the execution order of those works and add those dependencies. You can also add constant to work manager to optimize battery usage. Suppose you want to send some data to server. So you might want to implement set requires charging to true. So whenever user puts their device to charging, your work manager will start and it will make sure it will not drain the battery. Now let's understand quotas, which is a important concept if you are using work manager, because it limits the background work to preserve system health, and it is managed by Android system. We have three types of quotas. Execution time quotas, which limits the time for background work and it resets daily. So suppose if your app has a quota of 6 hours to run a work, and you are running two workers, one for 1 hour and one for 5 hours. So you cannot run third worker till your quota is reset. We also have rate limiting to restrict the frequency of work execution. It prevents the rapid fire task scheduling. We have concurrent work quota, which caps the number of simultaneous work items, typically limited to 5 concurrent jobs per app. So what happens your quota is if your quota is exceeds? So new work will be delayed, but existing work continues to completion. What you can do to ensure that your work is quota friendly. So you can batch related work item. You can use expedited work sparingly, and you can implement retry mechanism with backup policies. Let's talk about standby buckets. So previous slide, yeah, standby buckets. This is dynamically put by the system to determine which app gets more quota. So suppose if your app is active currently, user is using, so your app will get more quota than the app which is being in background and not used for a long time. So lower bucket means more restriction on background work. There are five categories to buckets. First is active. If your app is currently active, there is no restriction on background tasks. If it is in working set, so that means if it is getting used regularly but not currently active, then there are mild restriction on background tasks. If your app is used often but not every day, that falls under frequent category. So there will be moderate restriction on background tasks. Then there is rarely used apps which have significant restriction on background tasks. Starting from Android 12, we have another bucket which is restricted. So it is something if your app is using excessive resources, then your then system may put your app in restricted bucket. Yeah, next slide. So always make sure whenever you are implementing WorkManager, you test your app for quota and bucket permission. You can do that using ADB command set standby bucket, or you can use developer options and manually set to different buckets. Always make sure to add and test retry resume logic with backup policies so that if your work manager is killed by system, it can retry work later in the time. Now let's see how you can choose a right API based on your use case. To do that, you first have to ask yourself, does your work needs to be run when app is in background? If no, then you can use just threads for that. If yes, then ask if that work should be visible to user or it can be deferred. If yes, use work manager. Otherwise, check if there is any alternative APIs present for foreground service. If there is any alternate API, use that. Otherwise, you can use foreground service with relevant type. Let's see some examples. So suppose you want to build a music player app. What kind of which API will you use for that? Anyone? Uh, okay, no. Yeah, you can use foreground service with bound service. Bound service is used to give control back to activity. If you are building an app which provides some value to user, like a music player or a delivery partner app where user generally earns money through delivering orders, then you can ask user to disable battery optimization before receiving an order, let's say. You can check if battery optimization is enabled using Power Manager. This will make sure your task is not interrupting due to battery optimization. Let's say you want to build a location sharing app. What you will use for that? Which API will you use for that? You'll use foreground service with location fused API. To send data silently to server, we will use work manager. If you want to start a call through FCM, we can use telecom manager or phone call foreground service. If you want to send data to server on user click, then you can use user initiated task. If you want to schedule a task to run at an exact time, use alarm manager plus with expedite work manager, or you can use foreground service to if you want to run it immediately. Now we have talked about how you can run a work when app is in foreground, and then you can move in background while your work continues to run. But there are scenarios when you want to trigger a task based on a broadcast receiver or alarm manager or FCM. So to do that, you have to check if your task needs to be run immediately. Then you can use work manager, which ensure it will be run as soon as possible. If you if your use case does can't wait and you have to show something to user, you can check if your work will be done within 3 minutes. Then you can use source service type. You won't have to add any permissions for that. If not, then you can always use foreground services with and acquire a wake lock in case of broadcast receiver. You don't have to acquire a wake lock if you are starting a foreground service through AlarmManager or high priority FCM. If it's a broadcast receiver, make sure you finish your work within 10 seconds and ensure to free the broadcast receiver as soon as possible. Otherwise, it will cause a ANR. Starting, if your app targets Android 12 or higher, you can't start foreground service via app is running in background. Except for a few cases, you can check those on official documentation. For example, if you want to trigger a service which through a FCM, then you can only do that with high priority FCM, not on a regular FCM. If your task can be deferred, then blindly use WorkManager with resume and retry logic with backoff policies. So that's it. Thank you for listening. I have also created a sample project which you can scan the QR where you can just play around these APIs. You can also download slide link through this. So if you have any question, you can ask now if we are not short of time. Otherwise, you can connect me on Twitter or LinkedIn if you have any specific use case where you want to run a background.
Thank you very much, Ayush. And do you have any questions regarding WorkManager, regarding um, background work APIs? Okay, so I'll go with one. Like Android keeps putting more and more restrictions as we go, and like how we can maybe go and like if you have, for example, a task that needs to be run at a specific time, maybe you can like use an FCM notification along with WorkManager, or maybe like I see there's lots of APIs like JobScheduler, AlarmManager, and then now WorkManager. Like, what advancement did WorkManager like provide in terms of other APIs?
So if you want to be sure that your work should be done, even
Hmm.
if system interrupted due to low resources or low memory, then you can use work manager, but it will not guarantee that your work will be done at an exact time.
Exactly.
To do
Exactly.
that, you have to use a combination of foreground service and alarm manager and FCM and foreground service. But before using foreground service, always always check if there is any alternate way to do that work, because there are many ways you can do. I have only talked about three. You can check in
Yeah.
documentation, is there any alternative APIs.
Exactly. Yeah, I've
So
seen
the
like.
reason they
Mhm.
the reason they are putting so many restriction is it's easier to abuse these things, like if
Yeah,
you
to bypass the
developer can
DND mode or DOS
to
mode, yeah, for example.
yeah, yeah.
That's why they keep putting more and more restrictions like with these APIs. Okay, we have one question here about from Pritam. Tell me more about telecom services. How can I use this on FCM?
Okay, so to use telecom service with FCM, you just have to implement Firebase messaging service. You receive a FCM. It should be a high priority FCM. Otherwise, there's a chance that your device will not receive FCM because it was in DOS mode. Then, just like you create a foreground service, there is a connection service API which you can implement, and then you can, if you are using suppose a Agora SDK to connect user voice over IP, then you can add that logic inside that service. You can read that on official documentation.
I hope that answer your question, Pritam. And one last question. How can we use Work Manager to schedule a task that needs to run periodically? Even if the app is not running, how would you handle constraints such as device to be connected to a Wi-Fi network?
So to to schedule a task that needs to run periodically, you can create a periodic work request. Just make sure you do not uh, put repeat interval less than 15 minutes, because it will not respect
Mm,
that. It will only
yeah.
run after 15 minutes interval. And you can set those constraints which I talked while defining your work request. So suppose if you want to do a work while your device is connected to network, you can set network type unmetered. So with those constraints, you can do that work. You can read, there are many constraints provided by WorkManager, and you can read those detail in official documentation.
I hope that answers the question, Mahmoud. And yeah, I think that's it for the work manager. Thank you very much. That was very informative session, and I hope you all get the value from it today. Thank you very much, Ayush.
Yeah, thank you. Bye.
Thank you. Bye-bye.